Scientists agree that a relatively small number of simple laws govern the behavior of the natural world. However, science is rarely taught this way in our schools. A group of scientists and educators have identified 8 fundamental science concepts that every teacher and student should learn to gain a deeper understanding of science. These 8 concepts form the basis of 8+1 science.
What we have done in developing the 8+1 is to try to capture those laws and those basic concepts which help us to understand that natural world. Those 8 concepts, and hence what the 8 is in the 8+1, derive from 2 basic questions of what are things made and how do systems interact and change. The +1 has to do with the question of how in science do we know what we know, which comes down to data collection, inquiry, things that pertain to actually trying to study the natural world.
The power of the 8+1 fundamental science concept, I think, lies in the fact that they capture so much of what we know about how the world works. But these concepts are ones that are agreed upon by biologists, chemists, physicists, geoscientists, astronomers. We all agree that these are the basic ideas that allow us to explain almost everything we see in nature. So they're powerful in that they capture so much science in a few words. Their power in terms of teaching is that they allow teachers, curriculum developers, students, everyone to be able to see the connections between the sciences and not view them as separate collections of facts and formulas to be memorized, but that there's some coherence and that everything we know in all of these can be really summarized together in succinct and powerful ways.
Science is taught traditionally in different classes like biology, physics, and chemistry. We're really not envisaging that that's going to change. You'll still learn science in these different courses, but what the 8 fundamental principles do is they give you the tools that connect all the principles between these different courses. And you see that these things are all interrelated. They're all one thing, and they're all tied together by a very small number of fundamental principles that you can apply across all of these classes.
Teachers can use the 8+1 fundamental science concepts to build a coherent trajectory of learning as early as kindergarten. By providing a base of scientific understanding, teachers can build on the concepts as students proceed through the grades and encounter increasingly complex real-life situations, applications, and problems. Big things are made of smaller things. Scientists call this concept a system, and it applies to everything in our world. A city may contain many buildings. A building contains many rooms. Rooms contain people, tables, and chairs. Consider anything closely, and you will see that it is made of smaller parts.
There are very simple ways in which teachers can start to convince kids that stuff is made from very small particles. Opening a bottle of perfume at the front of a classroom, and the fact that before very long, whatever odor the perfume might be, the kids can smell it, all right? The perfume is the liquid. How did the particles of the liquid get to their nose?
When a student understands that every object in the universe is made of atoms, a window is open to understanding phenomena that were previously mysterious. What happens to the water in a puddle on a warm day? Where does the water go when it evaporates? As the molecules comprising the water receive energy from the sun, they increase their speed of motion within the water. Eventually, some speed up enough to break away from the water and move into the air, leaving a smaller puddle behind. This can continue until the puddle is gone. But the atoms still exist. They rise up to the cooler atmosphere and join with others to form water droplets, which clump together to make clouds and rain. Studying a disappearing puddle is really a lesson in big things being made from smaller things. Look at the variety of the plants and animals in your backyard. from the flowers in your garden to the bees that pollinate them. Diversity of life is everywhere. Young children grasp this concept early through exploring their natural environment.
The Earth is a complex system. Without life, it's still a complex system. Life brings to it complexity within itself. And the essential component of life, one of the basic concepts, is the cell. The cell contains many little systems. The cell is part of a system of tissues, of organs, of organism. Each of those is part of a system.
Cells are the building blocks of all life. Teachers can help students understand that all organisms are made of cells, which are structurally and functionally similar. When students look through a microscope to compare plant and animal cells, they begin to understand the biologic processes of their bodies and the food they consume. The study of unicellular and multicellular organisms helps students develop an understanding of metabolism, growth, and reproduction. Older students may study the development and delivery of drugs and the link between genes, cell mutation, and disease.
The 8+1 science concepts help build coherency through the grade levels. One of those concepts, for example, is that electromagnetic radiation is pervasive. When a scientist reads that, what we actually think is light is everywhere. Because for us, light is more than just what we see with our eye. It's radio waves, it's microwaves, it's ultraviolet radiation, it's visible radiation, it's ultraviolet radiation, it's X-rays, it's gamma rays. And we know from our knowledge of science in all fields that this radiation is literally everywhere. It's pervasive. And it carries energy and information, and that energy and information is relevant to understanding systems. It's understanding how energy gets transferred. And so every lesson in your classroom, from kindergarten all the way up to through the high school level, there will be the idea that light plays some kind of role to a greater or lesser extent. And so through the grade level, students begin to see this fundamental concept emerge. The visible light that comes from the sun ultimately is the source of so much energy for all of our energy in our food system, because it starts with the plants absorbing the energy in the light from the sun. So in that way, we find that all living systems ultimately are connected to the fact that light, or electromagnetic radiation, is found everywhere, that it is pervasive.
A system is a group of things that interact with each other over time. Systems can range from extremely small to large. An atom is a system of interacting protons, electrons, and neutrons. The solar system is comprised of the sun, planets, moons, and other bodies interacting primarily through gravity. A system can be any big thing that is made up of smaller things. This simplifying concept is a powerful tool for understanding science. Depending on the scientific question, scientists can pick any part of a system to study closely, isolate it with an imaginary boundary, and watch how it changes over time. By defining systems and studying how they change, scientists can understand complex problems. With practice, teachers and students can simplify problems in the classroom by building systems and studying how they evolve. Evolution is change over time. As time passes, systems evolve in different ways. Scientists seek to observe, measure, and understand these changes.
The 8+1 concepts can help students, children of all ages, learn about systems. The concept of the system really permeates most of the 8+1 concepts. When we talk about systems in biology, we might be talking about cells, we might be talking about organisms. They're all systems. In physics, we would talk about planetary systems. We talk about small-scale systems on the surface of the Earth.
What scientists choose as the size or extent of a system depends on the problem to be investigated. Sometimes it is useful to look at the problem from both the large and small-scale perspective. A galaxy could be considered a large-scale system if studying the stars and planets, but it could also be considered as a small part of another large-scale system when studying the universe.
As we take a broader view of life itself on Earth, we have to recognize that one of the defining aspects of life is that it is probably the most complex system of systems. In other words, at every stage, at every way that you can envision life, there are systems, and these systems are part of systems.
Scientists analyze how a system evolves with time by looking at how the big thing changes and at the motions and changes of the small things. The system boundary can grow, shrink, and change shape, and small things and energy can be observed and measured entering and leaving through the system boundary.
When the topic of forces is first introduced in elementary school, it's typically in the context of pushes and pulls, contact forces between objects. Those are the easiest to understand, how pushing on something sets it into motion, or how pulling on something can make it stop moving. Those are the familiar contexts of contact forces that are brought up in elementary school. But at the same time, forces are involved in almost all of the other science topics that an elementary school student is exposed to, like magnetism, like batteries and bulbs, like astronomy, because the same forces that we use to explain what happens when you drop something and it falls to the floor can also explain why the moon goes around the Earth. So there are many connections that can be made, and the more advanced we go in school, the more appropriate it is to bring in things like these forces that appear to act without contact, like the magnet's forces, and to go into more complicated examples of how motion can change in a way that's explained by forces.
Our lives are completely governed by energy. Yet, what is it? Energy helps us understand how things work and make predictions about how objects and systems will behave. Energy is all around us in the movement of things, electricity, heat, light, sound, or stored up to be used later in fuel or in potential energy. Understanding how energy is exchanged between parts of a system or exchanged between the system and its surroundings is one of the most fundamental aspects of science and the 8+1. Energy can be a difficult concept for students to grasp and teachers to teach. The key concept is that energy can be quantified, and in an isolated system, such as our universe, the amount of energy is conserved. It doesn't get less or more with time, though it can change its form and be exchanged between different parts of the system. By defining a system and tracking the energy flows, we can begin to understand phenomena, from weather patterns to how cells work, by placing quantitative limits on what is possible and what not. Just as a car cannot drive further than the gasoline in its tank allows, this hard limit applies to all processes where things are moving and changing. The concept of conservation can be extended to any quantity in a well-defined system. Scientists can study the evolution of a system to see which quantities are conserved and which are not. The gasoline in the car's tank is not conserved, but the atoms that it was made of are conserved. Where do they go when the tank becomes empty? Assuming the gasoline tank is not leaking, the only place they could go is out the exhaust pipe, because conservation of matter tells us that they couldn't just disappear. All that gasoline is now floating around in the atmosphere, although the atoms are recombined into a different chemical form. The understanding that some quantities are conserved can lead to powerful predictions about how a system will behave, and is an important clarifying concept for students.
Humans, as organisms, and all the other organisms, are part of the living systems on Earth. The key element in evolution of life on Earth is that it is driven by change in the physical and chemical environment over time. Change over time is inevitable. If there was no life, this planet would still change. And if you move from one place to another, you find that the environment has changed. How can you create and sustain life when change is forever going? That happens through the remarkable capacity of chemical and physical systems, which we now call life, to introduce error into the reproductive system. And the error results in variation. That variation and those errors are basically random. But that random error in the chemistry of life enables selection and adaptation to occur. Every organism that exists today varied and varied and varied over the past, and was selected for because it adapted to the environment of the particular age or epoch or time or place they found themselves. So variation is terribly important in setting up the potential for evolution as we define it in life systems. Now there's evolution in non-life systems, in planets, in solar systems, and that's different than variation in living systems.
Everyone has curiosity, but actually inquiry is more than just a curiosity. You can have curiosity and then you can have no tools for taking that curiosity and turning it into understanding. So it's partly scientific method, it's partly things you do in the classroom, and it's also these fundamental core principles that we're talking about that can take you from the curiosity to the understanding.
The process of inquiry can seem very complex when it's conducted by scientists at the Large Hadron Collider, for example, but it's the same process that children can participate in themselves in school when they're investigating what happens to caterpillars as they turn into butterflies, or when they're investigating what happens when they try to pick up things with magnets. It's the same process, and that's what unifies all of the science, is really the process of inquiry.
Inquiry is sort of, as I say, at the core of how we gain our knowledge. And we use our knowledge to make the decisions that enable us to move forward in all kinds of ways in which we live on this world.
In the world that we live in, there is so much technology, there are so many issues, nuclear proliferation, global warming, whether you should use a cell phone because it might affect your brain. There are all these issues, and if you are not scientifically literate, you have little opportunity to understand those things.
Teachers can use 8+1 Science to bridge concepts in the classroom and develop student thinking about how to solve problems. All science lessons can be related back to one, and usually more, of the fundamental concepts. An elementary science lesson on the water cycle relates to the concepts of atoms, radiation, forces, and energy. Middle school students can apply their understanding of these fundamental concepts when investigating if water boils faster in a pot with a lid. High school students can build on their understanding to investigate if hydrogen fuel is an efficient way to power their cars. As students progress through the grades and gain scientific knowledge, they can apply their scientific knowledge in a coherent manner to understand the world around them.
I think it's really important that we rethink the way we're teaching science, because I was brought up in a world of, metaphorically speaking, of educational silos, of vertical treatment of the subject matter. That today, those disciplines are coming together to explain much more fully how our world, the natural world, part of our world, operates. And the challenge is, how are we going to be able to bring them together in a meaningful way so that the children that move forward in the world today have a richer and deeper understanding of that natural world?
The 8+1 is not a new set of science standards. It supports basic concepts included in most standards for science and capitalizes on resources already available in the classroom.
The 8+1 provides a way for teachers to structure their thinking about the most important ideas in science and make the ideas coherent. And they can use it with any of our textbooks and any of our literature and any of the teaching supplies that we have. Under development right now is the next generation science standards for the country. But it turns out that the 8+1 fundamental science concepts is so flexible and so fundamental. The 8+1 can be easily adapted to them because they are the fundamental ideas of science. It provides a simple framework for teachers to latch onto, and it helps them interpret the big ideas of science to deliver to their students.
8+1 Science is a new way of thinking about science education and a new way of teaching science. Teachers are being trained on how to incorporate 8+1 in the classroom.
That's the beauty of the 8+1 concepts. They can be used across disciplines all day, every day, if taught properly. The 8+1 concepts does require an increase in professional development for our staff, and I think that's a significant shift.
What the 8+1 does is it enables them to restructure their thinking. They can look at what they're teaching, reflect on the bigger picture of what science is about.
By stressing the 8+1 fundamental science concepts, teachers can help students develop a coherent understanding of the vast amount of science content and facts, and help them apply their understanding to real-life situations, make predictions, and solve problems. These are 21st century skills that all students should possess.
Learning how to ask questions, learning to inquire about what things are made of, how systems change, it's just so significant in all of our work, in all of our disciplines, in all of our classrooms, and in all of our grade levels. As we really analyze the common standards, the curriculum being written for us, we have to find a way to teach those standards, teach that understanding, deal with high-pressure standardized testing in such a way that we also allow our students to develop a framework, a methodology, a system that's personal and will work for them not only in high-stakes testing, but far more important to me as a school superintendent after they graduate from our school system.
Implementing 8+1 science in the classroom gives students the fundamental understanding of science to succeed in our rapidly changing world.
What we have is a real chance here to really engage children in an understanding of science that isn't based on a lot of isolated facts, but really gives them a chance to understand the world, to think about the world. Facts don't help you to understand the problems of the world, climate change, nuclear proliferation, nuclear energy, should we have nuclear plants in this country? Those are all critical issues, and if we don't know how to think about those things, and we don't know how to engage in a dialogue about those things that reflects an understanding of science, we're going to make the wrong decisions as a society. And schooling is about helping children to grow up and be adults, to be good participants in a democracy, and be able to think through issues that are based in a scientific world. This is a crisis that we are in this increasingly technological world where that kind of knowledge is ever more important. we're just not giving our kids the kind of background that enables them.
Through 8+1 Science, teachers and scientists are joining forces to change the way science is taught. Our students deserve no less.